Hey everybody, and welcome back to the channel. I'm partnering with PowerGrid Inc. today to discuss the topic the BMW F10 chassis hardly sees any coverage on, and that's proper sway bar geometry after changing your ride height. So if you lowered your car, installed coilovers, or touched anything to your car suspension, then it's those details that make a much bigger difference than a lot of people realize. I've already got my ride height adjusted and dialed into where I want it, and today's focus is going to be installing PowerGrid Inc.'s adjustable sway bar end links and getting the sway bars dialed in at true ride height with zero preload. Before getting into the end links themselves, it helps to understand what the sway bar is doing. A sway bar is a torsion spring that connects the left and right suspension and resists difference in movement between the two sides by twisting. Because it works by twisting, the position it starts in at ride height matters. A neutral sway bar means it isn't applying force side to side while the car is sitting still. Factory end links are fixed length and designed for stock ride height. Once ride height changes, that fixed length can put the bar at a neutral. That's why adjustable end links are used to recenter the bar and restore a neutral starting position. Before these go on the car, I want to show them up close. These are PowerGrid Inc.'s adjustable sway bar end links, and you adjust them by rotating the center body to change the overall length. They use THK link ball joints with a peak resin liner, which is important because that liner controls friction, wear, and noise while still handling high radial load, constant movement, and misalignment. So this isn't metal on metal. It's designed to move smoothly and stay quiet under real sway bar forces. The link bodies are also rigid and weight optimized, so you get strength without unnecessary mass. That means the length you set here is the length the suspension actually sees under load. And one really nice detail, PowerGrid machines the wrench flats on the right-hand thread side, so you can instantly tell what direction you're adjusting once the link is installed. That also makes it easy to make small adjustments without having to remove the link from the car, which is huge when you're dialing things in at ride height. And because the threads are fine pitched, you can make very small, precise changes until both sides line up exactly the way they should. So while I got the car up in the air and the wheel off, this is a really good spot to show this, but when you measure center distance is the center of this hole to the center of the hole on the sway bar. And that's what's going to give you the length of your end link. So again, it's going to be the center of this hole to the center of this hole. And that's your center distance. And that's what's going to give you your length that you need for your end link. And you want to measure this while the car is at ride height. So like right now I got the wheel off, but you're going to want to have the wheel on, end link removed, and you're going to want to have the car on ramps so you can measure again the center of this hole to the center of this hole. And that's your center distance. And when I was going over centering distance, when you get your center of your hole to your center of your hole, your center distance will match the length of your end link, which will be, I'm trying to fix it right now, the center of this stud to the center of this stud while it's straight. On the BMW F10 chassis, the lower rear sway bar end link mounting point uses a recessed conical bore in the rear lower control arm. When installing an aftermarket end link with a straight shank or flat face stud, a spherical washer, also known as a safety retaining washer, must be used. The spherical washer allows the ball joint to self-align with suspension travel, maintains proper seating in the control arm, and prevents side loading of the stud. This preserves OEM joint geometry and ensures proper articulation of the rear sway bar under load. I want to pause here and go over the recommended adjustment process because this is important. The instructions are very clear. You always start with the adjustable end link set to their shortest overall length. Final adjustment is done with the vehicle sitting at true ride height on the ground or on ramps with the suspension fully loaded. The goal is not to measure a specific length, the goal is to remove preload. So before we do anything in the front, what you want to do is have one end link installed in the rear and only one in the rear only before we sit the car down. Because you don't want to throw off your front adjustments and you don't want to chase your tail. So the best bet is to always just install one end link in the rear and then we could do the fronts. And to start this, because we're going to go into the nylock, is making sure we use a 19mm wrench and a 6mm Allen key so we can hold the stud. And then we'll torque it. So once you get them wrench tight, then the torque specs, it'll be 45 foot-pounds for the M12 side, and then it's gonna be 35 foot-pounds for the M10 side, which isn't really a lot of torque. You don't want to over-torque these either because you don't want to break the link itself. When you're doing the M10 side, it's a lot easier to use an 18mm flat wrench and just a ratcheted socket, since this stud is a lot longer. And the M10 studs actually provide a flat that you could put a wrench, you don't need an Allen key for. You can actually put a wrench behind it. In this clip, I'm installing the driver's side sway bar end link with the wheel removed for access. I'm starting at the top connection on the coilover. Installing the strut side first helps locate the end link naturally and makes the lower connection easier to line up afterward. These end links use spherical bearings with the link ball captured in a PEEK resin liner, which allows smooth articulation while keeping the joint properly supported. The hardware is started by hand to ensure clean thread engagement, and the joint is kept square on the mounting surface. At this stage, the fastener is run down snug but not fully tightened. Final tightening is done later. With the top connection installed at the coilover, the end link is now positioned correctly to finish the lower connection. Underneath the car, the lower connection at the sway bar can be secured. I'm installing and tightening the lower mounting nut while keeping the end link aligned so the bearing isn't loaded at an angle. This secures the end link while still allowing the joint to articulate as designed. All end link adjustment needs to be done at true ride height with the suspension fully loaded. Because this car has a dedicated driver, I'm using sandbags to approximate driver weight during adjustment. This helps ensure the suspension is sitting where it actually operates on the road. Even small side-to-side ride height differences can introduce sway bar preload, especially with stiffer bars. Adding driver weight helps remove that variable. If you don't have sandbags, any secure dead weight can be used. The goal is to simply mirror real-world operating conditions. At this point, the car is sitting at ride height, and I've added sandbags in the driver's seat to simulate my body weight. That way, the suspension is loaded the same way it is when the car is actually driven. Now I'm adjusting the end links. The first step is to loosen the jam nuts on the link. Once those are free, the center body can be adjusted. You can use a 7mm or 9/32 wrench on the adjustment flat to rotate the center section. If you take notice, I placed my adjustment flats on the bottom part of the end link so it's easier to reach while the car is at ride height. I'm turning the center body until the link is completely free to move. Most of the time, it's the passenger side that needs adjustment since the driver weight naturally biases the suspension. A neutral sway bar is achieved when the center body can rotate about a quarter turn in either direction by hand without resistance. That tells you the bar isn't applying force side to side at rest. Once the link moves freely like this, the sway bar is neutral at ride height and ready to be locked down. Now with the rear of the car on ramps, the suspension's still fully loaded and sitting at ride height. The jam nuts are already loose so the center body of the end link can move freely. What I'm checking here is whether the sway bar is neutral at rest. A neutral sway bar means it's not applying static force side to side while the car is sitting still. To confirm that, I'm rotating the center body by hand. Neutral is achieved when the adjustment rod can rotate about a quarter turn in either direction without resistance. You don't need all four end links to move freely at the same time. Neutral is confirmed when this free movement exists on 2 of the 4 cross corners of the vehicle. That tells you the sway bar is relaxed in its operating position and not preloaded. Once this condition is met, the rear sway bar is neutral and ready to be locked down. Alright guys, that's it. So if you lowered your car, installed coilovers, or adjusted your ride height at all in any way, your sway bar geometry should always be checked. Adjustable end links are the only way to retain a neutral bar and eliminate that preload. Huge shout out again to PowerGrid Inc. for supporting the BMW F10 platform and also providing me an opportunity to share this with the community. Thank you all again for watching, and if you have any questions or comments, just please comment down below, or you could send me a DM on Instagram. And again, thank you again for watching, and I'll see you in the next one.